Hi, welcome to Computer Science Explained. In this video, we will talk about fixed binary fractions. Binary fractions can be divided into two groups, fixed point and floating point. In the fixed point binary fractions, the position of the point does not change. Number of bits of integer part and number of bits of fractional part are constant. For example, we have 8 bits in total. We can distribute all these 8 bits between integer and fractional part in different ways. But our design choice cannot be changed afterwards. So number that is stored does not affect distribution of bits between integer and fractional part. In the floating point binary fraction, the position of the point can change. A number that is stored affects the position of the point. Both fixed point binary fractions and floating point binary fractions can be unsigned or signed. Signed binary fractions can use all types of notations: sign magnitude, 1's complement, or 2's complement. Let's consider an example of an 8-bit fixed point binary fraction with 4 bits for the integer part and 4 bits for the fractional part with 2's complement notation. We have the number 01011010. This number is a positive number because its MSB equals 0. Let's convert it to decimal. -8 times 0 plus 4 times 1 plus 2 times 0 plus 1 times 1 plus 1 over 2 times 1 plus 1 over 4 times 0 plus 1 over 8 times 1 plus 1 over 16 times 0 equals 5 and 5/8, or 5.625. Let's consider another example. 10110100. This is a negative number because its MSB equals 1. Let's convert it to decimal. -8 times 1 plus 4 times 0 plus 2 times 1 plus 1 times 1 plus 1 over 2 times 0 plus 1 over 4 times 1 plus 1 over 8 times 0 plus 1 over 16 times 0 equals -4 and 3/4, or -4.75. Let's consider an example of a 16-bit fixed point binary fraction with 10 bits for the integer part and 6 bits for the fractional part with 2's complement notation. We have the number 0001001101011000. This number is a positive number because its MSB equals 0. Let's convert it to decimal. 64 plus 8 plus 4 plus 1 plus 1 over 4 plus 1 over 8 equals 77 and 3/8, or 77.375. Let's consider another example. 1110010100101000. This is a negative number because its MSB equals 1. Let's convert it to decimal. -512 plus 256 plus 128 plus 16 plus 4 plus 1 over 2 plus 1 over 8 equals -107 and 3/8, or -107.375. Now let's consider the influence of bits distribution between integer and fractional part on precision and range. We will analyze two examples with the same number of bits, but with different distributions of bits between integer and fractional parts. First example: 2 bits for the integer part and 2 bits for the fractional part. In total, there are 4 bits. As I said in the video about bits, the number of variants that can be represented using n bits equals 2 to the power of n. So in our case 2 to the power of 4, which is 16. We can use a gap between two contiguous values as a precision criterion. The lower the gap, the higher the precision. This gap can be calculated as 2 to the power of a negative number of bits of the fractional part. So in our case 2 to the power of negative 2. As we can see in our example, the gap equals to 1 over 4. The range in our example is from negative 2 to 1 and 3 over 4. Range length equals 3 and 3 over 4, so almost 4. Second example, 3 bits for the integer part and 1 bit for the fractional part. In total there are 4 bits. In the second example, the number of variants is also 16, because the total number of bits is the same. In the second example, the gap equals 2 to the power of negative 1 and equals 1 over 2. The range in our example is from negative 4 to 3 and 1 over 2. Range length equals 7 and 1 over 2, so almost 8. We can see that in the second example the gap is 2 times greater, or in other words, precision is 2 times worse, because there is 1 less bit for the fractional part. But the range length is almost 2 times greater, because there is 1 additional bit for an integer part. The position of the point for a given number of bits represents a trade-off between precision and range. Thanks for watching. See you next time.